there's a half here. So that's why we write the P1. So this is your correct P1 in complex notation. All right. So after this, we have the P3. Yeah. So from our P3 is here, right? Okay. So our P3 is here. So we just substitute our solution. So our P3 is this, and then last time we have solved the chi I x x x. So as I said, if we apply all the field in the x direction, so because of the crystal is simple, so the I here you change to x, then you have the px3, px in the third order, bracket 3 is third order. And we have solved this, we have solved this yellow one. So this one, you solve it, then you get terms like this. Okay, I hope that I'm right, but the concept is there. So you have to make it right if I'm not so correct. And then we have this free field. Here I do not substitute yet because here is the general formula. Here is already the workout. So this you have the one conjugate. You see this is conjugate, positive omega here. This is conjugate. This is complex. Okay, so that's why you have the conjugate and complex. And then you substitute. You know that you have already solved your chi1. So your conjugate of chi1, you just change the I to positive, right? The other don't change. So this is your chi complex. Okay, chi complex, as in the P1 just now. So in your P1, so the complex, and then is the okay your equation. This is the conjugate, right? This is, so these two are complex. You can filter down your constant to over 8, and then this one you can simplify. So altogether you have this term, you have this term, and this term you have 3 of it, so powers of 3, and then the conjugate of it you have 1, and then you have things simplified to this. So this is your P3x. So this is your P3x. Okay, this is your P3x. Okay, so I derived up here. So can you follow? Is it okay? Okay. Yeah, so you need the time to do all the details and make the full understandings. Okay, so you know that our wave equation, let me see, this is our, just now we derived the wave equation. Okay, so that's why you know that once we have solved this, we can substitute this into this P equals to P1 plus P3. Okay, this P here, we can make it this. Okay, so our P1 is here. All right, so by right, I can substitute all the E's. Okay, this is our P1, and then plus the P3. Yeah. Okay, maybe I'm a bit too fast. Let me just show you the steps. We have the P1 plus P3. Yeah. Okay. So this is our P1 that we have just solved, and then this is our P3. All right, and then all the E's we say that it is the okay, right? And you know that our E naught x here actually is equivalent to I want to use a symbol. Let me see. Letter of it. So set our direction of propagation. Yeah? Okay. So this is after the substitution. I try to make it third. Okay. So L square actually is dx plus d square over dy square on the square. So I copy paste this again. So this one become not d, del, still del. Del over del z. Sorry, z square. This del square won't operate on the this time factor, and the second time derivative of this will give you minus omega square minus omega square. Okay, so you have this. You have done the time derivative. Okay, so the same as you have minus omega square of all these, because time derivative of this term will operate on this. Time derivative of this will operate on this also. So you have this become minus. Okay, so you take away the time derivative. Maybe I just spell it out. Let's put it here. Okay, you can see the screen. Okay, after this I can simplify. So I have done all the time derivative. So every term carry this. Every term carry this time factor. So what should I do? I can just cancel it. I can just divide every term by this time factor. Okay. So I just delete this. Delete the time factor. Then you can see the equation becomes simpler. So after this, we just need to solve the z dependence of the this amplitude. Okay, so let me see. That